Now we'll talk about RISC-V, because RISC-V is the first one to really adopt CHERI. And we have Andy Moore from RISC-V International. And Andy drives awareness and adoption of RISC-V across its global member ecosystem as Director of Marketing at RISC-V International, and with deep prior experience at ARM. Yeah, we were in the same office at one point. He brings a rare mix of process IP marketing and hands-on engineering experience. So it's up to you.
Thank you. Where's the buttons?
Keep down.
Click down. Okay. Nice to see everybody here. I'm going to just do a bit of an intro on RISC-V, and then we've got Tarek, who's going to give you the details on what's happening inside the ISA. But yeah, just to start on RISC-V, I'm probably telling you things that you already know. It's a very educated audience, but RISC-V, just to cover what we are, RISC-V is an open standard instruction set architecture. We hear people quite a lot talking about open source architecture. RISC-V is an open standard. There are open source implementations that people do on it, but we are an open standard. So, obviously the ISA is what the software uses to tell the hardware what to do. RISC-V ISA and extensions are ratified by RISC-V and are royalty-free, and they're base building blocks for anybody to build their own solutions, as it says on the slide. So essentially, people can use the RISC-V ISA royalty-free. They can extend it. They can do what they like with it. RISC-V is, we're the home of the ISA, and we have a membership, a worldwide membership. If you have a look on the website, you'll see all these different companies, from very, very well-known ones that you'll know, big tech companies, to small startups and research institutions. So there's lots of different people inputting into the standard. And standards is something that are really, really important. Global standards are a catalyst for innovation. They always have been. Over the last decades, things like Bluetooth, Wi-Fi, lots of different standards. They've been critical to technology adoption and standardizing things and allowing technology to proliferate. They create access to opportunities and they spur innovation. And so RISC-V, we're a standards-defined instruction set architecture, and we're developed by a global community. And that community is really worldwide. We see our membership as a third Asia, a third America, a third Europe. And also in terms of people contributing to the standard, we see contributions from all geographies. So it's not that there are contributions in one local geography specifically. We have contributions from around the world. And that's one of the amazing things about RISC-V. RISC-V really enables worldwide innovation. In terms of talking standards, the latest big news that we had was RISC-V is now an ISO IC pass submitter. It's a bit of a mouthful. But what this means is that we have been approved by ISO to be able to submit our standards, our ISAs, to become hopefully global standards. So we are recognized as a submitter now. We had to go through some different processes and reviews to make sure that our standards and the way that we work is up to scratch for this, but we passed. So this was announced last September. So now the work starts on making the RISC-V ISA manuals become actual ISO standards. This is an exciting thing for us to be doing. And also, if we turned 15 last year, so 15 years ago, there were discussions in Berkeley about what ISA they should use to do their research on, and should they actually start a new one. And 15 years ago, well, 16 years ago now nearly, they agreed that they should. So if you want a good overview of RISC-V over the last 15 years, have a look at this blog. We did a lot of work on it to bring it together, so it's well worth a read, and it gives you really the whole background in the organization. So what's great about RISC-V is that it allows people to invest locally and engage globally, which sounds very marketing, but what we are kind of meaning is that everybody around the world has different requirements of what they need to do with compute, and the different problems that they have. And so it allows people to do things that are specific to their problem, but also with access to a global market and a global ecosystem of knowledge. So if you look at different people who might want to use RISC-V, countries can use RISC-V for tech sovereignty. Brazil is a member of RISC-V, and they are, it's basically the national architecture for Brazil, from universities to, to their companies. It allows them to accelerate innovation and train talent and incubate technology ecosystems from research into industry. So it's really important for them. Multinational companies can, gain strategic control of their product roadmaps and introduce new business models and avoid things like vendor lock-in. So it's great for those companies. Researchers, I mean, RISC-V started with people wanting to do research on, on computer architecture. You can do interesting new things that you can't do with other architectures on RISC-V. You can really extend, change, do whatever you want with the standard and come up with some really interesting new research and solutions. And in terms of startups as well, you can create things that you wouldn't have been able to create before. You can optimize in different ways you couldn't do before. You can find other partners for collaboration inside the RISC-V ecosystem. It's a really powerful way of getting a compute startup going. And we really are kind of going places. This is some research from the SHD group in terms of market penetration. So you can see we're going from 2.5% market penetration at the start of the decade to the start of the next decade will be 30%. I have 5 minutes more, right? Yeah. So I'll try and be quick. So you can see, I mean, the penetration is really, it's growing massively. So, new designs are happening on RISC-V, and this goes across all industries. If you look at the different industries that we're interested, that we're looking at, automotive, Infineon have already said their future MCUs are going to be on RISC-V. Data center, Fabian has a data center. He has RISC-V in the data center already. Definitely talk to him about that. Consumer, there are laptops based on RISC-V. Again, talking about Fabian showed me an e-reader at the break. Have a look at that. It's based on RISC-V, this tiny little cool e-reader. Space programs, NASA and the European Space Agency are both basing future compute architectures on RISC-V. There's people like Frontgrade Geisler who are working on IP for space in Europe. HPC, we're seeing is again, NVIDIA announced support for CUDA on RISC-V. There's all sorts of support happening across a vast range of verticals and horizontals. So RISC-V really is going to be everywhere. And what we need to do to make that happen is we need to think about how we grow the software ecosystem, we grow the hardware ecosystem. And one of the big things that we did last year was, the year before last, was we announced the RVA23 profile and ratified it. And so with RISC-V, as I say, you can use the extensions you like to create the IP, to create the processing that you want. But what we need to grow an ecosystem is a standard profile, which then the software ecosystem, the hardware ecosystem can coalesce behind. So RVA23 is a profile which addresses a lot of different market segments. It's really good. RVA23 is for more application-based. RVB23 is the more embedded part of that, but they're both ratified now, and they're really important for pushing things forward and really growing the software ecosystem. And what you can see here is, we have the core ISA on the left, and there are extensions to that ISA that are developed inside the working groups. We then build profiles out of those extensions and ratify those. So the profiles are standard base for people to work from and build applications from. And then on top of that, we're also looking at platforms. So there's server, platform, and development. We're working on mobile, automotive, different platforms. And so we're trying to create ways to make RISC-V work and be adopted across lots of different application spaces. Not long to go. So in terms of talking security, I want to shout out Andrew Dello here. He's the person that you need to speak to as the chair of our security organization. We've got a lot going on in security. We've got a white paper. Somebody asked about the TEE white paper this morning. It's here. You can download it from risc-v.org/security. We have new security extensions in process across, a lot of different extensions happening just now, and the CHERI profiles are also in progress. So, as RISC-V, we see CHERI as an important direction for security. It is a really interesting direction for security. It's something that we're really, we're interested in, and RISC-V is really the only architecture that can unleash the potential of CHERI as we see it. It's really the way forward for CHERI as far as we're concerned. So the CHERI profiles are in progress, and it's really exciting to see, there's already solutions being delivered. Codis have their X730. SCI just recently announced their MCU. Javier talked extensively about what you're doing. There's lots of great stuff happening there. Microsoft was involved with CHERI as well. There's loads of great stuff happening. So, it's really exciting to see the future of RISC-V and CHERI and what's happening together with us. So that's basically an overview of what we're doing. Tarek has got a lot more interesting things to say, technically, but does anybody have any questions?
if needed. Anyone? Questions? Yeah, it was very clear. That's the thing. Okay.
I don't have anything. I just wanted to let you throw the cube.
No, well, one thing which we expect is when standard profiles will include CHERI by default.
Sorry, when will they
The
include CHERI by
the
default?
RVA and RVB and RVM.
I work in marketing.
Okay, so you say very soon, right? Okay, so no more questions? Yes.
Sorry, you can through it. I'm possibly the only non-computer scientist person here, so this could be a really dumb question. But how does ARM and CHERI, as two Venn diagrams, how does that work going forward?
How does ARM and CHERI work for it?
ARM holdings and RISC-V, how does that, in the big Venn diagram, how much is that? Are they going to go this way, or what are they going to do?
I have no idea.
Oh, you don't
It's
have
not-
an
I
you don't
can
have an
only-
opinion about
I
it?
can only talk to what, I can really only talk to RISC-V. I'm afraid you'd have to speak to ARM about that.
Okay. All right.
Sorry.
No one ever answers that question.
Good try. Okay. I won't put the ARM people in the room on the spot, so I will put the thing here. And thank you very much for your presentation.